Okay, let's keep going with these relationships and how everything works out together. Let's look at example 4. Find each of the following. And do you also see how important it is? So like in that last section that we just did here, how important was it that we automatically know that sine and cosine's relationship with tangent, the reciprocal identities, back and forth, reciprocal identities. That's why I said way back in 9.1 or whatever it was, we got those basic identities down. You have to know those. We're going to use them, and we're going to use them all the time. For instance, I want to find the cosine of theta given that secant theta is equal to 5/3. Well, what do you know about the relationship between cosine and secant? Yeah, they are. They're totally reciprocals of each other, right? So if secant is 5/3, what is cosine? And it's just that easy. It's just that easy. Don't make this more complicated than it needs to be. It's just straight up exactly what it is. Okay. Now let's do this thing. Part B is I want to find sine of theta given that cosecant is equal to negative square root of 12/2. Now why are they going to do that to you? Why would anybody ever give you the square root of 12? I don't know. Why? Why am I saying why is anybody going to give you the square root of 12? Because you can break it down. You're exactly right. I can right now break this down to say I'm going to take the square root of 4 times the square root of 3. Well, we know the square root of 4 is 2. So this is really the cosecant of theta is equal to negative 2 square roots of 3/2. And what do you see about those 2's? They go on. So this is really the cosecant of theta is equal to the negative square root of 3. I like that we're looking at this because how am I going to figure out sine of theta when I don't even have a fraction over here with my cosecant? How am I going to make a reciprocal of something that doesn't have a fraction? Yes, good. Just like you do anything else, right? You put that over 1. So my sine that I'm coming over here is going to be negative 1 over the square root of 3. Good. Now, let me tell you something right now. If you put this on your paper, I would take that all day long. That does not bother me, but I will tell you, my math lab is going to have you rationalize the denominator. So, if I now have sine of theta is equal to negative 1 over the square root of 3. To rationalize that, we're just getting it out of the denominator, that radical. So multiply the top and the bottom by that square root of 3. Remember back to your previous radical information coming into this class. So sine of theta is now negative square roots of 3/3. Because the square root of 3 times the square root of 3 is just 3. And that's square root of 3. Okay. I'm okay with this answer or this answer, but I think my math lab wants this second answer, so make sure you rationalize that denominator. All right. Okay, let's look at some more. I think we might be able to pull this off. Let's look at some more relationships here. I want to identify the quadrant or quadrants, plural, depending, of these different functions. Oh, how about that? Identify the quadrant, or plural, if there is more than one, of theta with the given conditions. Okay. I know that sine is greater than 0. Oops. Sine of theta. You can't have just sine out there by itself. That doesn't make any sense. It's a sine of an angle measurement. You always have to have that angle measurement in there. And then tangent of theta is less than 0. It doesn't make sense to write sine or tangent or any of the trig functions without that angle measurement. Okay. What does this mean? If I have something greater than 0, what does that actually mean? Positive. All right. What does this mean if I have something less than 0? Negative. So let's think about this here for a second. I have sine has to be positive. So if sine is positive, that's going up. Right? That's where it's positive because my y values are positive because sine represents y. So my y values are positive above the x-axis. If my sine values are positive, how am I going to get tangent to be negative? Yes, right? If sine has to be positive, I'm up here in quadrant 1 and quadrant 2. Those are my only choices. Because I'm narrowing this down. If sine is positive, then I know I'm going up. The only way to make tangent negative is if cosine is negative. So where is cosine negative? Yes. So when cosine is negative, so which quadrant do I have to be in to satisfy these conditions? Quadrant 2. Do you see that? So this basically is just an exercise in making sure you understand sine is y, cosine is x. So when are these positive and negative, and how does that work? All right, so you just have to, this is just a think through exercise. Okay, let's try another one. When cosine is less than 0 and secant is less than 0. All right. What do you know about the relationship between cosine and secant? Yeah, they're reciprocals of each other. So there's 1, 2, 3, 4. When cosine here is negative and secant is negative, that's happening in the same place. Here we are. Oh, cosine is negative. If cosine is negative, then secant is also negative, and that's happening in 2 quadrants. Because neither one, cosine or secant, have anything to do with the y. So because of that, then I know that this is what's happening. Quadrants 2, Roman numeral 2, and 3. Right? On the last problem, we had both x and y coordinates, so that made an impact to make sure that we knew what was going on with that. But if I don't have both x and y coordinates, if I just have an x coordinate, such as in this instance, then you just go with that.